Hi guys, so I will be solving number 13, which reads, after falling from rest from a height of 30 meters, a 0.5 kilogram ball rebounds upwards, reaching a height of 20 meters. If the contact between ball and ground lasted 2 milliseconds, what average force was exerted on the ball? So in order to first solve this problem, I drew a diagram which basically rephrases the question. So the ball was dropped at a height of 30 meters, stayed in contact with the ground for 0.02 seconds, which is 2.0 milliseconds, and then it bounced off for a height of 20 meters. So in order to first solve this problem, you need to know the final velocity right when the ball hit the ground. So because it was dropped, you would know that the initial velocity is 0 meters per second, the displacement is 30 meters, and then the acceleration is 9.8 meters per second squared. So in order to get the final velocity, we would use this kinematic. And so the final velocity when it hit the ground was 24.24 meters per second. Next, we want to find the initial velocity when the ball took off to the ground. So we know that the final velocity is 0 because that's the maximum height when it rebounded. The change of x is 20 meters, and gravity is negative 9.8 meters per second squared now that we're going up. So the initial velocity when it took off to the ground, by using this kinematic, we got 19.80 meters per second. So now that we know the initial velocity, which when the ball hit the ground, and the final velocity when the ball left the ground, we can figure out the acceleration while the ball stayed in contact with the ground. By using this, velocity final equals velocity initial plus acceleration times time to solve for the acceleration while it was on the ground. So we get that the acceleration is 22,200 meters per second squared. So with this information, we can finally solve for the average force that was exerted on the ball by the force equals mass times acceleration equation. And the mass was given in the problem, which is 0.5 kilograms. And then the acceleration we solved for, if you multiply that, you would get 1.1 times 10 to the 4th newtons.